On-prem agents, Wiz. Let's go. What a great way to round out 2024, huh?
Yeah, who would have thought this is where we'd end?
That's right. That's right. It's really cool. We saw some evolution happening even within the last week or so from LangGraph and from the folks over at LangChain. And we've actually got some new things that we're going to cover today, including LangGraph Platform that actually has LangGraph Server implemented, which is a little bit different than LangServe, right?
Yes, we have entered the platformification era, and so there's the names be changing, but ultimately it's the same technology we know and love, just bundled in an easier package, a prettier present for the holidays.
That's right. That's right. That's right. So it's still serving the Langs we love. It's just a little bit more, let's say, mature heading into the next year, something like that, right?
A little bit more production ready, yes, I would say.
A
Yeah.
little bit more enterprise grade. Excellent. Excellent. But there is a free version and it is open source, and that's the one we're using today. Isn't it so?
Yes, and it does the thing, and we're gonna see it do the thing, and that's basically all you want. Yeah.
All right. And we're also going to wrap up the year with talking about agents and agentic RAG and RAG and how you might think about these differently in an on-prem context. I'm excited for today. How about you, Wiz? Last one of the year. Let's go, baby.
Can't wait. I can't wait. Let's go.
All right. We'll see you back in a bit as we kick off discussion. Let's go ahead and rock and roll with on-prem agents today, guys. If you have questions along the way, if you have comments, throw them in the chat. We'd love to hear from you guys, especially during the discussion components. All questions will be answered at the end if you put them in the Slido link. So please do use the Slido to put in questions and upvote your favorites. We'll cover the latest and greatest from LangChain and LangGraph today. We'll talk about agents and how to build them on-prem, what kind of requirements you need. And we'll also discuss some of the differences between using an approach that we get from LangChain versus using an approach that we get from like a Llama index. So this is going to be a great way to wrap up the year. Let's get ready to rock and roll with on-prem agents. All right, so as we kick off the old sesh, let's make sure we understand exactly what it is that we're aiming at. We want to understand on-prem and we want to understand agents. We've covered these before, but we're going to give a quick review and primer here. We also want to understand the LangGraph platform because this is sort of a new structure. It's an evolution that's taken place over the last year, and it's important to stay up to date on what's going on right out at the LLM edge, especially as these tools and technologies like LangGraph and LangChain mature. We're going to discuss, because it's quite interesting actually, agents versus agentic RAG versus RAG in an on-prem context, because the compute and memory requirements you need are actually different depending on what exactly you're looking to build and do. Then we're finally going to build an agent research assistant. Shout out to LangChain folks for putting one together right in time. So we're going to go ahead and stand on the shoulders of giants a little bit with one of their recent repos they put out this week and give our own flavor to it. And then we're going to discuss some of the latest releases they've had this week to sort of close out the sesh, including LangGraph Command and LangGraph Interrupt, and give you our 2 cents. So with that, let's go ahead and get into on-prem agents. We will, again, talk about the platform. We'll also mention the model hosting. This is just sort of for those of you that are maybe slightly more beginner, the inference server versus the API server, these are different things, and we really want to zoom in on that, and then we'll build. So on-prem, when we talk about this, what we're talking about is it's right there with you. What's it? Well, the stuff you need to run your models, to run your apps. It could be at your house, like it is at Wiz's house today. It could be at your business. It doesn't really matter. Now, that's what on-prem is, I just want to be super clear, like what on-prem isn't. You don't need on-prem to do production grade applications. You can do them on-prem or you can do them in the cloud. Production simply means running and not going down. You might also consider, like, do I need specific types of hardware on-prem? Like, do I need GPUs with video RAM on-prem? And the answer to that is like, yes. Okay, you do. Because LLMs run on GPU. That means both chat and embedding models. And depending on what you're building, you might need one or both. These things run on GPU and they care about how much memory we have. This is a really, really important, probably top level important thing if you want to do stuff on-prem. And of course, GPUs are quite expensive. So are the models that we typically are trying to run on them. So what we'll use today is we'll actually use a version of Llama 3.2 that you may not know about this, and I didn't really know about this, that they have text-only versions that are great for on-device. It's not just a multimodal LLM. So we're going to go ahead and pick up the 3 billion parameter model because it's more lightweight and still very, very performant. So if we're looking at on-prem, we might also consider looking at things like on-device models, right? Makes a lot of intuitive sense there. Our device is, in fact, on-prem. Now, the next question we need to ask is, what about CPUs? What about RAM? What about hard drives? Do these things need to be on-prem? Yeah, of course they do. And, you know, as we think about the types of requirements we need when we go on-prem, it's going to depend on what we're building. We're talking about on-prem agents today. And when we use agents, we may or may not use some of these other pieces, like embedding models, vector DBs, and creating robust data pipelines. Today, we're talking about agents, though. So let's be real specific and define what we mean by agent. Our definition of an agent at AI Makerspace is a system that can leverage or emulate reasoning or equivalent to make dynamic decisions in an application flow. And in order to create an agent, we need to really define what that means to us. Because, as we all know, requirements really do matter. What we're building and why we're building it really does matter. And we hear a lot of variations today about on-prem, in the cloud, RAG, agents. We might really take a hard look at this heading into 2025 if we want to spin something up on our premises for either ourselves as individuals or for our teams to leverage, because the compute requirements for things we need to build are actually different. If we want to build a RAG system, for instance, we're going to need an embedding model for the query. We're going to need it for our data. We're going to need a vector DB corresponding to the embeddings we create with our data. We're also probably going to need a pretty robust data pipeline if the data is changing from time to time and something we need to update. Whereas if we just want to build something like we'll build today, where we're leveraging sort of a simple agentic flow that hits the internet, comes back, talks to the LLM again, well, in that case, we don't really require an embedding model, a vector DB, some sort of robust data pipeline. We can actually get away with much less. How much less? Well, these are important questions. And the answer, of course, as all good questions are answered, is it depends. And of course, we can have agentic RAG, where we kind of have all of the above. We have our sort of proprietary database, and we can pull from it. Maybe we're leveraging some sort of internal API to hit it if we're doing this on-prem. And we're also giving our agents access to things in the way we would with simple tool calling, simple function calling, agentic flows. So when we go to estimate the requirements, the first thing that we need to do is we need to say, well, how much data? What are the models, right? And like the most classic thing ever in machine learning is just exactly that. So none of this is new. The new part is really when we talk about agents. Now, we've talked about agents many times on this channel, and we'll talk about agents many more times in 2025. We've typically given a few different agent definitions. One of the ways you can talk about agents is sort of in an agentic RAG capacity, where you're augmenting and enhancing search and retrieval to do even better RAG. Like to say agents are a fancy RAG. You can also use agents in a simpler way, where you avoid RAG altogether and you're simply giving them access to tools or APIs. The simplest one, and one of the ones we'll leverage today, is a simple web search. How can we give the agent access to the internet to do search? And this sort of meta pattern that's kind of always at play is this react or reasoning action pattern. So we're going to focus in today specifically on the function calling, the simple agent, not the react or not the fancy RAG, agentic RAG approach. The react pattern and the simple function calling agent are sort of one and the same thing. In fact, we can take a look at what we're building today by looking at a simple reasoning action loop. We're going to have some sort of query, some sort of question that we're trying to answer. We're going to try to do some research today. And our agent is going to take some action. That action is going to have some observation, some sort of result that we're pumping back into the agent to consider and reason through and think through again. Now, that might be enough just to hit a quick Google search or something like that to get our final answer. In this case, we're doing summaries of research that we found. So sort of a final summary to answer a detailed question that we asked. Now, what kind of actions are we going to be taking today? This is where it starts to get a little bit more interesting. Well, we're going to leverage the web research. This is from the Rabbit Research repository, or the Research Rabbit repository on LangGraph. And we're also going to be able to summarize the research. And there's one additional step. So when we go into our toolbox, when we go and we use function calling, we're typically going to go to the web search, and then we're going to sequentially move to a summary step. Now, you can leverage kind of different LLMs for different parts of this, including the third part, which is to reflect. And this is where the reflection agent comes into play here. But we're going to stick with having just a sort of Llama 3.2 setup where we use one LLM for each of these steps. Remember, we define agent or agentic system as a system that can leverage reasoning to make dynamic decisions. Basically, it can reason and it can decide, it can act within our application flow. When we think about reflection, this is actually an idea from the paper on reflection, language agents with verbal reinforcement learning. This is kind of a tough definition here directly from the paper. A reflection agent is one that verbally reflects on task feedback signals, then maintains their own reflective text in an episodic memory buffer to induce better decision making in subsequent trials. That's a lot of words that are probably a little bit overcomplicated. So let's take a look at this idea of the reflection agent, and let's consider that each time we're going back to our agent, we're sort of managing this conversation thread. And this conversation thread and everything that we hold in it, from our web research to our summaries, this is what we are reflecting on, okay? Simply the conversation that we're having. That's the memory buffer. That's the sort of episodic different loops. And that's the sort of crux of what it is that we're really doing here. We're going to build, again, an on-prem, a local researcher or research assistant. This is another way that we can sort of visualize what's happening. We give it a topic. We're going to go ahead and go to the LLM. It's going to do some research. It's going to create or update our summary. And then we've got this sort of other LLM pictured here that's sort of doing the reflection. Again, you can picture this a number of different ways. This is directly from the LangChain repo. Now, this was obviously built with a very common piece of visualization, block diagram software that you've probably all seen many places before. You can also visualize it directly through the LangGraph Studio IDE. And the reflection piece, as we go to sort of from the query into research, doing the summary, reflecting on the summary, the reflection piece is actually going back to the research based on that thinking through and that reflection. Now, this is a quite simple setup, actually. This is really kind of as simple as some of the useful agents you might build out there. We don't necessarily need the summary piece. We don't necessarily need the reflection piece. Those are sort of a little bit extra additions, but really this is quite simple. It's much more simple if you joined us a few weeks ago than when we did the TPS report generation using Llama index, and we sort of tried to assess dopeness of particular amounts of data. This was an agentic RAG setup, and it's one that we actually had to put quite a bit more work into. We needed an embedding model. We needed a vector database. We needed to make sure that we built out our data pipeline. Whereas when we talk about what we're doing today, when we talk about this research rabbit that we picked up directly from the LangChain repo, they put this out this week on LinkedIn. We saw it, thought that was perfect. This is not leveraging all of that. We don't really need to do all of that. And so one of the interesting questions when we talk about on-prem setups heading into 2025, I want to bring Wiz back up for this, is like, if I have a simple setup like this, Wiz, where I don't need all this extra stuff, at least in theory, I don't need all this extra stuff yet. How can I think about my requirements, both from an LLM perspective and from an agent perspective? Like, how much GPU, VRAM, CPU, and RAM do I really need?
Yeah, I mean, this is not really a question that we have the answer to out of the box. This is very much, just dependent on what you're doing. Even for these simple things, right? If you use the 1B model, well, that needs less, resources than if you use the 3B model, and performance will appropriately scale, right? So I think it comes down to at the end of the day, like what kind of performance you're looking for, and that performance is largely going to dictate the actual resources that you need. Just to give a non-answer.
That's right.
To the question.
That's it. So the performance, you mean sort of like, how long will it take someone to get a final answer from our research report after giving it a topic? Like, what's the latency for a final answer kind of thing?
Sure. What's the latency? That's a great way to think about performance. Another way is like the accuracy. How well, how good is the report? What's the quality of the report? On all facets of performance, our resources are going to be taxed as we want things to perform better, right? If we want a better report at the end of it, a better model is going to lead to a better report, which is going to require more resource. And if we have the same pool of resource, well, maybe now the model is running slow, but the report is generating accurately. And then we need even more resource for it to generate fast and accurately. And you can imagine how we get in the situation where we're talking about nodes and clusters very quickly, right? When we're thinking about on-prem.
That's right. That's right. So, okay. So I'm imagining, I'm a developer, Christmas is coming up. I either have some Christmas money coming in or, maybe I'm going to give myself a gift here. And I want to be able to build on-prem dope agentic apps. Okay. So like, all right, that's my goal 2025. Like, I know we've talked about this before with the GPU, but are there CPU requirements that you'd recommend for people today? Can I get the MacBook that is like basically standard and I can kind of get very far with it, or do I need to spend, $4,000 on the MacBook right now to be able to build agents? Or does that just make people feel cool and they really don't need it?
Yeah, I mean, if you want to build on-prem, it's going to cost you money no matter what. We've talked about this before. Would always recommend getting kind of a 4090 or 3090. Pick your poison. If you want to just get started, but that's not going to serve a lot of customers, right? So you're immediately going to have to purchase more hardware. If you just want to tinker and build and have a great time, get the MacBook. Whatever M series chip, right? It works well with ollama, which we're going to be talking about today. And that's really all you need to like tinker and play, right? Prototype. Once you get into, trying to build a performance system, you're going to need to care about things like, are your compute resources high uptime? How do you handle when they go down or something breaks, right? You immediately get into a much more complex, much less straightforward engineering problem once you move past that prototype phase on-prem.
Okay. We got one quick question in the chat here. Can we set up on-prem systems with Red Hat 8.x to execute Gen AI stuff?
Sure. I think Red Hat can run K8s, so that's all you need, right? You just need a path to, as long as there exists a path to K8s, you can use whatever operating system you want. I think even Windows can do K8 stuff through WSL, so your OS shouldn't be a limiting factor.
Okay. All right. So basically, to recap, like agents, we're not talking like we need some massive CPU, some huge amount of RAM, especially for the simple, straightforward kind of function calling agents. This is something you're going to get out of the box with any kind of standard latest laptop you get off the shelf.
Yeah, I mean, you can run this on a MacBook, and it will work. You just need, whatever 24 gigabytes of unified memory, right? We don't worry about the CPU and GPU on a Mac. It's all the same box. It'll be good enough if you have the M series. So.
Good enough. All right. Well, thanks, Wiz. We appreciate those insights, and we're going to go ahead and introduce the LangGraph platform next, everybody. So we'll see you back in a bit for the build. Okay, so with that in mind, on-prem agents, let's take a look at the latest and greatest tooling from LangChain. The LangGraph platform is really a rebrand of the LangGraph cloud. Came out Halloween this year, so not that long ago. And we're going to use the self-hosted light version, which gives us access for free up to 1 million nodes executed is the language that they're using. And it's kind of a limited version of the LangGraph platform, but we can run locally, we can self-host, we can do stuff on-prem. There are also other enterprise options. If you're interested in those, definitely check those out. Now, how did this come about? This is the more interesting thing for us, right? How did this really come about? Well, the evolution was kind of like, we did an event on this agent IDE, the LangGraph Studio idea. It turned out a lot of people really liked this. We thought it was cool too. We actually thought it was a no-code builder when it came out, but it wasn't. But it still really is a useful tool to sort of debug and visualize and accelerate application development for these types of applications. So this came out, and then LangChain realized, oh, people love this. They love it so much that they actually want to be able to use it on their own hardware. They don't just want to use it in LangGraph Cloud. They released a desktop version of this. So that's kind of where this began, at least in the story that they spin. Now, additionally, LangGraph Server was something that people were finding to be quite valuable. This idea of serving applications up that are built with LangGraph is not new for LangChain, but this is kind of where the agents met the serving a little bit. LangGraph, really for those agentic flows, and then serving kind of came together here. And what LangChain heard is that really using this LangGraph server was a lot easier. It was a lot easier than, for instance, a previous solution that we actually thought we were going to cover today. And interestingly enough, we covered last December 14th, almost exactly a year ago, we covered LangServe for the first time. But this is a tool, it's the same idea. You can deploy a LangChain application directly to an API that people can hit. It never really caught fire in the industry, as we saw throughout the year. And even as of this week, you can see on the docs, they're recommending to use LangGraph Platform instead of LangServe. So that's exactly what we're doing today. And then finally, the nail in the coffin for going with the plat. On-prem, baby. We've got a lot of people out there. They're like, hey, data privacy is way too important. I'm not going to use LangGraph Cloud. They're like, we've got to be able to hit internal APIs. Can't use LangGraph Cloud. And so, they listen to their customers. They listen to many developers out there like you guys. And they realized, well, actually, let's do something that allows for either cloud or on-prem for people with strict data privacy requirements or for people that need to connect to internal APIs. So the evolution was really that LangGraph Cloud, which was previously obviously a cloud solution, was now replaced with LangGraph Platform, which can do both. Look at that. Maturity, evolution. 2025 is indeed on the horizon. So LangGraph Platform has three primary components here. It's got LangGraph Server, very similar to this idea of LangServe, where we can serve up the application. It's got LangGraph Studio, where we can visualize, debug, use it to accelerate application development. It's got the command line interface and the software development kit, classic. And it helps us deploy and scale. All right. Okay. So we're going to use this today. And we're also going to, importantly, none of this hosts LLMs for us. So we have to do that separately, no matter whether we're building just an agent or a RAG system or an agentic RAG system. And as Wiz mentioned, we're going to use Ollama. Ollama, as we talked about before, it's really quick and easy, very, very useful, allows you to deploy stuff locally, and you can really take it anywhere. As we've discussed in a recent event on VLLM, it's not necessarily going to, be the hyperscale, super fast solution for everything in production as you grow things out. But, you can take it anywhere, like wherever your premises are. Again, we're going to leverage some efficient models, the 3 billion off the shelf, Llama 3.2. This is text only. This is not a multimodal LLM. And to be super clear about the servers that we're going to use here, Ollama is going to be the inference server. So that's the one that hosts the large language model. The LangGraph server is going to be the API server, the application server. This is the one that we're hitting so that we can basically say, here's my topic, give me back the report, do it all. And I'm personally a little bit curious to see, can we get some more visualizations from LangChain about what's going on inside LangGraph server? If not, that's something that I'm quite curious to build out here for you guys that follow us at AI Makerspace. So let's go ahead and get into the on-prem research assistant today. It's called on LangChain's repository Research Rabbit. And Wiz has whipped up a special AI Makerspace edition so we can get Gentic on-prem today with you guys. Wiz, over to you.
Oh yeah. Okay, so we're gonna do something terrible, which is share the whole screen for just a few moments. So this is what we're working with today. The idea is that we have a number of things that are rolling. So what we want to be able to do is we want to be able to use this Research Rabbit, and we want to be able to use it in our LangGraph Studio, and we want that to be hosted through LangGraph Platform. So we have a series of steps that allow us to do this. We have two different terminals here. One is going to be running a local studio version, which we can use to debug, play around, and test. And then the other is going to be running our actual deployment through LangGraph Studio. So this is running on my local machine, and then this is running on my living room server. So what I would say is important to keep in mind here is that there does exist this separation between like the debug, prototyping mode, and then that we've pushed this thing to quote unquote production. Also, you'll notice that we have our ollama set up, so we can do cool things like talk to this Llama 3.2 model, like, how are you today, right? You'll notice that the inference, once the model is on the GPU, is very zippy. This is because it's a relatively small model, right? So this is all of what we're working with, just to give you an overview, right? And now what we'll do is we'll dive into each of these components. So first things first, we got to talk about what the actual application is doing. It's going to be this Research Rabbit from LangChain. You'll notice that we have our LLMs, just going to be our chat ollama model. We have the LLM in JSON mode as well, so we can leverage JSON mode since the Llama 3.x series of models support that JSON mode. Then we have some nodes, generate query. Unsurprisingly, this generates a query. We have web research, which is going to be a tool use node. We have summarize sources, which is going to be another kind of tool use situation. We're going to think of it as such. We have reflect on summary, which is going to be a node that allows us to reflect on the summary we got from that other node. And then we have our finalized summary, which is kind of like locking it in. And then we have route research, which is going to tell us where we need to go. You'll see here that what we're doing is we're just going to loop a set number of times in this simple agent. And then we're going to escape to our finalized tag. So all we want to do here is make sure that we have the actual nodes set up, which is pretty classic. You're used to nodes at this point. And then what we're going to do is we're going to build our graph. Once we've built our graph, we're going to go ahead and run our graph. Now, you'll notice as well that we have this interesting file structure where we have some prompts. These prompts are pretty straightforward. All we're going to do is we're going to think about them as, instructions. This is normal agent stuff, right? So nothing too weird or crazy at this point. And then, of course, we have our state. Our state is pretty simple given the actual application, right? So what we have is the research topic, what our query might be, what our results have been, what sources we have so far. You'll see when we look at the application why this is important. And then we have our research loop count. So this is how many times we've gone in a circle. And then our running summary. This is our summary so far. And that's it with the entire thing. This whole deduplicate and format sources is just going to build a list that's not filled with duplicate links in case we get them. Okay, so that's the application. Okay, that's dope. Now we're going to go ahead and see how it works, right? So we've got this cool application. We're very excited about it, and we're going to go ahead and we're going to look at how it works. So in the LangGraph Studio, which you'll notice, or you might not have noticed, but I'm on a Windows machine, and I'm looking at LangGraph Studio, right? Now, LangGraph Studio is running in the Docker container. We're accessing it through that smith.langchain.com, and we're able to see, even on our Windows machine, LangGraph Studio, though we can't launch it as a desktop app, which is okay. You'll see here that I've already done a research query, which is how is Llama 3.28b instruct trained by Meta. And you can see as we go through the steps, first we generated a query, then we did some research, right? After the research, we summarized, then we reflected on the summary, and then we did some more research, and then we, and on and on. You kind of get the idea, right? So we can add a new thread here, and we can do new research like, what is an LLM agent anyway? And then we can submit this, and then we get the beautiful visualization as our system works through the steps in order to solve this problem. So that's just working through those nodes we created in that Python file earlier. Okay, so that's that. I'll just let this thing run. That's fine. What we want to do as well, now that it works, is we want to go ahead and get it running on our remote machine, right? In this case, a different server. So what I've done is I've already set this up so that we can access it. You can see here that we can access our docs, which is going to be how we use this service. It's got all of the instructions we could ever think about or want, thanks to the documentation that has been created for this service. Because it's using the OpenAI or OpenAPI structure, the docs look very good and are very robust. And that's all been delivered through the LangGraph platform. So in the first instance, we just kind of have this LangGraph server here running by itself. And then we have our LangGraph platform running the separate instance. This is extremely important because it lets us wrap this whole thing in that platform, which is more than just the actual component of, or more than just like the LangGraph graph. So if I once again stop my screen, and then we're going to share my terminal window, which will be lots of fun, which we can share here. You'll see here that we have this terminal window. I'll go ahead and zoom in so it's less, it looks less tiny here. And the idea is pretty straightforward. We're going to go ahead and run things down, and we're going to go ahead and look at our Docker Compose. When we have our Docker Compose, we've talked about Docker before, right? But Docker Compose, what it does is it has a bunch of different services. So we have our LangGraph Redis service, we have our Postgres service, and then we have our actual LangGraph service. So this is the idea of, or the reason why we say this is more production ready, right? Because it's not just this kind of naked API chilling out there in the wild. We have our Postgres service. This is a database. That database is going to handle things like threads and assistant interactions and all kinds of other fun things. Redis is going to act as a pub sub for how we're actually interacting with the services. Because many people might be using the service at once, there might be many background threads running, and we need to be able to highlight those to the correct users. There is one limitation with this build as built out specifically, which is that Ollama doesn't support concurrent generation. So this is not going to be something that you plug and play into production. You're going to want to or need to look for something like VLLM in order to bridge that final production gap. But very few code changes are required to do that. And it works well for a single user with Ollama. And that's it. To say that's it it's a lot, right? We have this idea of Docker Compose. We have this idea of all these other things that we're using. And if we can finally just Docker Compose up, right, which is going to spin up all of these services, Postgres, Redis, and then, of course, our favorite, the LangGraph API. And this is, all gotten, quote unquote, for free. All we had to do is build that Docker Compose file. They already have an example on the in the documentation for LangGraph Platform, and then we spin it up, and that's it. We're away to the races. We can start using this service with some reliability. That's the whole thing. That's the whole shebang. So with that, I'm going to pass you guys back to Greg. But before I do, I got to ask you to, for the last time this year, in fact, don't forget to subscribe and ring the bell, icon on YouTube. We're live every Wednesday doing events like this. Most Wednesdays, we won't be live for the next two due to them falling directly on holidays. But there you go. Back to Greg.
All right. Good stuff, Wiz. All right. I want to remind everybody, go ahead and throw any questions you have in the chat. We'll have some time. But I wanted to go ahead and also introduce some of the latest drops that we saw this week from LangChain / LangGraph. And the first of these is called LangGraph Command. And LangGraph Command was dropped on December 10th. And, this whole idea of like these crazy drops we've been seeing from the industry, from OpenAI, from Google, it seems like LangChain, LangGraph got in on the action here. So I want to kind of have a little discussion about this. The kind of couple of things they pointed out with each of these are really important, and I think maybe it sums up to something, again, maturity 2025, what's coming next. LangGraph Command basically said requiring edges to connect nodes turned out sometimes it could make it harder or less intuitive to express very dynamic logic. So basically LangGraph Command is this idea of edgeless graphs, and edgeless graphs allow us to more easily build multi-agent architectures. And this idea of sort of no edges is quite interesting. So I want to just kind of actually pause here before we go to the next one and bring Wiz back up. Why would we care so much about edgeless? This feels like some of the discussions we've been having around event-driven architectures versus graph-based architectures. Is this how it sort of you interpret this as well? Or is this something specific that you would expect them to roll out so that they could be more production ready?
Yeah, I mean, it's just all about how you're thinking about having multiple agents, right? I think the idea of like an edgeless graph lets us kind of emulate the pattern that Llama Index has, not directly, but it does let us have more kind of easier time to build out these more complex graphs that doesn't require us to have like 40 lines of boilerplate with conditional edges. Remember the idea of conditional edges is they're kind of maps that tell you where you can go next, right? Command helps us kind of do that in a more in a less verbose, less manual way. I would say is the way to think about it.
Yeah, so I guess the idea of having conditionals for everything does sound like it doesn't quite scale particularly well. So, from that perspective, there's some intuition there that I think makes a lot of sense. So they released this command piece, and then they released 4 days later, this was, on December 14th, LangGraph interrupt, which allows you to interrupt LangGraph, and we've talked about this before where state machines are a little bit more flexible than fully autonomous agents. And the reason is because you can basically track state and you don't necessarily want things being totally autonomous. So, like as we sort of look at this idea of putting humans in the loop more easily, they give a couple of examples here where we're talking about, should a human approve or reject the next action? Should a human approve or reject the next state? Should a human approve or reject the next tool call? Should a human approve or reject the next agentic reasoning flow here? And so, what do you think, Wiz, about these new releases? Are these things that are going to move the needle for people in 2025? We're sort of trending more towards this maturity and enterprise grade thing. They seem to be listening to their customers quite well. The naming's not so bad. I don't hate the naming. Like, these don't necessarily deserve dedicated events from us, but what are your sort of high level thoughts on some of these new releases from them?
Yeah, I mean, we didn't live in a world where we needed to build these specific kinds of multi-agent systems or agentic systems until recently, right? So we're still seeing these frameworks and libraries and et cetera, really figuring out what patterns do we need, what patterns are fundamental or core to the experience to create like a well operating agentic system. So things like command, which are more so like helping developers, and then things like interrupt, which can make sure we have this idea of being able to gracefully and appropriately basically pause and start graphs, right? Lets people interact with them in a way that would feel natural, in a way that would be desirable, but we didn't yet have the construct for it. It is, again, we're all in exploration phase right now. Multi-agent systems exist technically in production, technically, right? But they're not like it's not solved, and so the tools that we need aren't solved. I'm very happy to see LangChain continuing to push forward and help create some of these tools so that people can build better applications than they did in 2024 when it comes time for 2025.
Yeah, definitely. And, and I think like, it seems like the shipping velocity has also kind of, increased as everybody is kind of dialed in around agents. We're seeing sort of a lot of people really move towards this and move their product towards this as well. We're doing our best to define agents here as we head into the new year. When people hear agents, when you hear agents, and you're sort of hearing about the new agentic release, how would you encourage people to think about what matters, what doesn't matter, how to sort of pick and choose, how to separate signal from the noise with some of these new tooling that we're seeing, some of these more, they're kind of coming from everywhere, whether it's Crew AI or Swarm or Llama Index or LangChain, or, everybody's getting in the game now. What are the most important things from your perspective to pay attention to when it comes to agents in 2025?
Yeah, I mean, they're not solved. This is still a big play space, right? I think keep trying to innovate, keep trying to just try things. I mean, we're still in the phase of like basically like the prompt engineering equivalent of agents, right? So it's just get out there trying things, use different frameworks. Definitely we're going to recommend LangGraph and LangChain, but try out different things, poach patterns from other frameworks and research that you see. In terms of separating signal from noise, it's very difficult right now because we just don't know where something like a multi-agent system really prospers. We don't have super clear, consistent case studies, and so it's kind of all noise right now. But pay attention to Agent Force, pay attention to folks like AG2, who are going to hopefully help steer the ship a little bit. Other than that, it's just it's all over again, Chat GPT, but this time with the agents.
Ooh.
And 2025 is going to be fun, and hopefully we're going to lock in a few use cases that make sense and leverage the technology in a way that adds value to businesses.
Yeah. And my one last little comment on that too is everybody's releasing these sort of like study of who's using agents, and there's a lot of sort of feedback going on LinkedIn and elsewhere where people are talking about, well, yeah, like that percentage seems high. Like, yeah, I mean, the people that are answering the surveys about agents are the people that fundamentally know about agents already, right? So they know about LangChain, they know about LangGraph, they know about Crew AI. So yeah, there's this whole world of people that are not out here that I think it's going to be really, really interesting to see how they decide to use these tools in the year to come. So let's go ahead and open it up for Q&A after we sort of draw some conclusions from today for everybody to keep in mind. When we build on-prem agents, we want to make sure we have the agent hardware support and we have the LLM hardware support. RAG is going to add other stuff. So if we're doing agentic RAG, we're going to have to keep that in mind. And when we just want to tinker, we can go far with something simple. But if we want to scale out our app usage, we're going to have to scale out our hardware. So if you do have questions, please let us know. We wanted to add a little bit extra time today just because it is the end of the year and it is our last event of the year. We really appreciate all you guys joining us throughout the year. We do have one question. I'm starting to see them coming in the chat. I do not worry my data leaving my prem. Could I use a Grok LLM in that research application? I think this is talking about Grok hardware because it's Grok with a Q, not Grok.
Yeah, you can use, if you don't care about data leaving your prem, you use whatever API you've got access to.
Yeah, easy. Will my data leave the network if I am using LangGraph Platform on-prem? Like, do I need to worry about it going to LangGraph server hosted somewhere and somebody seeing it? I think this is the indication here.
I believe the answer to this question is technically dependent on whether or not what you consider your data. The short answer is no. The long answer is some data does escape through traces, things like this, depending on the integration that you have with LangSmith, what you're tracing. So this seems to be configurable though, which means that you don't have to share any data outside of your premises. And certainly with the enterprise solutions or even the cloud solutions that they offer. So this is everything kind of past like the free tier. You have full ownership. The data never leaves your your AWS world. It never escapes. Yeah.
Next question. How are you guys thinking about sizing / complexity for agents versus assistants? That's an interesting versus there. For example, in setting up a large orchestration agent with many sub agents as nodes. How are you thinking about sizing And
yeah, at the end of the day, I think it would be very difficult to want to reach for very complex agents. I think when the great part of LangGraph, right, is that it's kind of like these little atomic graph units, right, that we care about. And so, I'm content to have 2 or 3 subgraphs per kind of meta level. But getting past that, I think you just wind up in this like hyper complex space where you have no idea what's happening. And even with great tools like Studio and Langsmith, it's very hard to trace through and understand and debug what's happening in that application. So, creating little subgraphs or sub agents as nodes, right? We still want them all to have very limited scope, especially because we just don't know yet, right? What the best patterns are. They haven't been figured out. They haven't been trialed and tested. So I would say keeping complexity as low as humanly possible, right, is the goal. And so that's how I think about sizing. What's the absolute minimum that I can get away with, and the thing still functions?
Okay. So 2 last questions to end with. The picture behind me, guys. This one, The Attributes of the Sciences by Jean-Baptiste Simeon Chardin. It is something that I'm waiting to update until we get the attributes of the AI sciences in an image. So if you guys get one, maybe I'll print it off and put it behind me. Last one, I love this question because it's very similar to a question that we got yesterday as we're beginning to close out our final course of the year, Wiz. And that question yesterday was, is there anything you'd put in the course that you couldn't put in the course? And we said kind of no, because that's the way we design our curriculum. This question is, Dr. Greg, if you started a second PhD today, what would your topic be? Or I would say, Dr. Wiz, if you wanted to get a PhD today, what would your topic be? And I think like this is such an interesting question because you and I were talking about this last night, Wiz. It's like the stuff I studied during my PhD in optimization and computational design, and Wiz, your background is in sort of general physics. These sort of backgrounds really did prepare us quite well for navigating the LLM edge today. Like I spent a lot of time in gradient descent. I spent a lot of time learning the old school perspectives on optimization algorithms. You can look at things like PPO and DPO today when you talk about alignment. And, it's like, I guess for me today, what I would do, knowing what I know now, is number one, I wouldn't necessarily decide on a topic. I would decide on a research group and a professor or an advisor that I really, really thought was the best. And I would really drive towards working with the absolute best. So here's a little insight into advice I've given previously, which is reach out to the research advisors you dream of working with. Set up a trip to literally go there and ask, can you give me a walkthrough of your lab? Do you have any open projects? The most successful professors always have open projects, and they're always hiring new PhD students. Show the initiative, show that you've studied the background on these LLMs, show that you're really, really in to staying up on what's happening at the edge, show you watched the Ilya talk from last week, show that you're sort of there and you're willing to go wherever it is that you need to go. And, that'll be sort of, if you're into this stuff today, that'll be sort of the best way to stay right there at the edge and continue to be useful. Like, Wiz, what's your 2 cents on this? If you had to pick a thing to study today, what would it be?
That's an impossible question to answer. It would probably just be more LLMs, man. Like, I think unfortunately you already gave the best answer, so I would just copy that, right? Like, find the people working on the problem that you think is important, and then do anything in your power to work with those people on those problems. I think you don't have to be doing a PhD to do that, to be clear. No. Don Branson from our community, just submitted a PR to AG2 because he likes that, right? He's contributing. It's never been easier to be part of the research community right now, because the research community is, if they're exploring, right? They're trying to find what's next. Ilya just gave his big talk where he says data is fossil fuel and all this other wild stuff that's got people in a fervor. And we're trying to figure out what the renewable energy is right now of AI, just to extend his, however you may think about it, just to extend what he was going for. And it's never been easier to contribute. It's never been easier to help as an academic, as a non-academic. This is the time in quote unquote AI history that we need those ideas. Foundation models are plateauing. All we have is using them and using them the best. No one knows the answer to that question yet.
That's right. So. And at NeurIPS, you were at NeurIPS this past week or so, and you mentioned that research today is not just in academia. It's very much also in industry, and this has been true at OpenAI, but it's also true elsewhere today. It's true places like Google. It's true at places like Amazon. It's true at the large tech companies as much as it's true in academia now. And I think this is an important insight that wasn't the case when I was studying optimization, 2010 to 2015. So don't sleep on industry. Is that a fair insight from your time?
Don't sleep on industry.
All right. Thanks, Wiz, for your insights. Thanks, Wiz, for the demo. And it's time to wrap it up, guys. Thanks for joining us for our very last YouTube live session of the year. We're going to be back for 50 more next year until we take a little time off between Christmas and New Year's 2025. So look out in the newsletter for what's coming next. And please don't forget to keep building, shipping, and sharing over the break. Now, if you're looking to accelerate everything that you're doing and really, really try to get out to that edge as quickly as possible, you might consider joining us for the AI Engineering Bootcamp, cohort number 5. That's going to kick off January 14th. It's going to be a banger. We've got some amazing peer supporters ready to help out. We've got really the most agentic and state-of-the-art curriculum we've ever had. And I'm really, really excited for everything that comes next. So hit me up if you have any questions about that. And again, have a great holiday season, everybody. Thank you for supporting us this year. You guys are our early adopters, and we really do appreciate your support. We look forward to following your journeys in 2025 and beyond, whether they lead to PhDs, industry, or otherwise. And although we'll take a little time off, you best believe I'm going to be cooking something up, and I'll be building and shipping. And if you jump into the Discord, you might just see what we're ready to share over the holiday break. Until next time, we hope you guys keep building, shipping, and sharing as well. Merry Christmas and Happy New Year's, everybody. See you in the new year.